Hello, welcome to m251 Calculus 1 here at Cañada College. My name is Ray Lapuz and I'm the instructor for the course. In this video, we will go over section 4.8, Hopitals Rule. The idea behind this is to recognize the forms, the indeterminate forms, so you know when you would actually need to apply Hopitals Rule. So by identifying the indeterminate forms, that's going to give you the key to say, hey, I'm probably going to want to use the rule. And so there's two main indeterminate forms, and there's another set of 5 other forms. So a total of 7 forms that you're going to be able to use Hopitals Rule. And also the idea behind the ratios in Hopitals Rule talks about how fast the numerator and the denominator are going with respect to each other. And usually we want to consider these things as you go off to positive or negative infinity. So finding out the growth rates of different functions and comparing them would be a good thing to be able to do. First, the idea behind Hopitals Rule. So there's 2 cases that we eventually want to come down to. And the first case here is talking about the 0 over 0 case. And the second case is talking about the infinity over infinity case. Now, if you have a 0 over something that's not 0, then that would be approaching 0. And if you have something over 0, then that something is not 0, that usually means that something's going off to infinity. But if you have a 0 over 0, they're kind of contradicting each other. And so we're interested in finding out how fast one of them is going with respect to the other. So the idea of not comparing the functions, but comparing the rates of change of the functions becomes important. And so that's where the derivative comes in. So Hopitals Rule allows you to find the derivative of the numerator separately and the derivative of the denominator separately, not the quotient rule, but finding the derivative of the numerator and the derivative of the denominator separately. You're then comparing the rates of change of the function on top and the function in the bottom, and then finding the limit as it gets closer to 0 or another number or even infinity, and then you get to see what's happening. So these are the 2 main cases where you can apply Hopitals Rule. All the other indeterminate forms will have to be rewritten into these 2 cases for you to be able to apply Hopitals Rule. So here are the next 2 types of indeterminate forms. The 0 times infinity. You know that 0 times anything should equal to 0, and infinity times anything should equal to infinity. But now if you have 0 and infinity, you have a competing rates of change, and which one's going to go to 0 first or infinity first, we don't know. And this is where you get to apply Hopitals Rule again. But before you get to apply Hopitals Rule, you have to write it into a fraction. So for example, if you have an x ln x, as x goes to 0, this is going to be 0 times infinity. And so to be able to deal with this, you want to rewrite this into a fraction. And when you rewrite into a fraction, then you take the limit, and then it'll go either 0 over 0 or infinity over infinity. And in that case, you get to use Hopitals Rule. So you don't get to use Hopitals Rule directly with 0 times infinity. You have to first make it into a fraction. And once you have it in a fraction form, then you get to apply Hopitals Rule. Our 4th example of an indeterminate form is infinity minus infinity. So again, it seems like it should be equal to 0, but it's not always going to be the case. It depends on how fast each of these terms are going to infinity. If the first one goes faster to infinity, then it might be infinity. If if they go about the same time, it might be 0, or it might actually be a number. So an example would be something like this. We have 1 over x squared minus 1 over tangent x. And if you put 0 in there, that's going to be infinity minus infinity. And so what we want to do is, again, try to change it into a fraction. And by combining common denominators and make it into one fraction, you'll see that this new fraction now will have a tangent x minus x squared divided by x squared times tangent x. And if you put 0 in there, now you have something of the form 0 divided by 0, which is the first of the two kinds of indeterminate forms that we saw where you can actually apply L'Hopital's rule directly. So these transformations from these forms to 0 over 0 or infinity over infinity did not use any L'Hopital's rule yet. So you would use L'Hopital's rule once you get it into that form, and then you just take the derivative of the numerator and the derivative of the denominator and be able to come up with your conclusion. Now, the last three types of indeterminate forms deal with powers. 0 over 0 is indeterminate. Infinity to the 0 power, 0 to the 0 power is indeterminate. Infinity to the 0 power is indeterminate. And strangely enough, 1 to the infinity is also indeterminate. So, if you try to reason things out, we know that anything to the 0 power is equal to 1. But if something's going to 0, something's going to infinity faster, it might not equal to 1. It might equal to 0, it might equal to infinity, or again, it might be somewhere in between. The 1 to the infinity is another strange case. We think of something going to infinity as going to, if raising the power to go to infinity, it would go to infinity. If the base is bigger than 1, or if the base is less than 1, it would go to 0. But if it's approaching 1, we don't know exactly what's happening. So we're going to have to use L'Hopital's rule because it's indeterminate. Now, again, we can't use L'Hopital's rule directly because L'Hopital's rule only applies to fractions. So somehow we have to write this into fractions. Now, if we have powers, and writing it to fraction might be quite difficult. And so we're going to need to bring that power down as a coefficient. And so this is where an ln comes in. So for example, if you have x raised to the 1 over x power, and this is going to go where x goes to infinity, we're going to have infinity as a base, and then the power is going to go to 0. So this is the infinity to the 0 case. The idea is to let y equal to that function, and then you take the ln of both sides. And when you take the ln of both sides, you get to rewrite your power function, or your exponential function, or that something to the something function, and write it as a fraction. So once you write it as a fraction, then you're able to apply L'Hopital's rule for that case. And you take the limit, and once you take the limit, you're going to get an answer. Now, that's not your final answer, because remember, in the beginning, you took the ln of both sides. And so if your limit happens to be whatever that limit is, you have to remember to undo the ln that you did at the very beginning. And so by undoing the ln that you did in the beginning, you're raising it as a power of e. So it's going to be e to whatever limit that you found. Now, this is just a simple example. You can look at a few more examples in the textbook or in the checkpoints, but the idea is just take the ln, take the limit, and then undo the ln. So in taking the limit is when you're probably going to be applying L'Hopital's rule, but remember to take the ln first, and remember to undo the ln by raising it as a power of e. Okay, so this 1 to the infinity one is quite popular, and in fact it comes off of this particular limit. Limit as n goes to infinity of 1 plus 1 over n, all raised to the nth power. I don't know if you've seen this before, but you might have seen this in a pre-calculus class when they were doing compound interest. And you start compounding continuously, you let the number of compounds go off to infinity, and then you get this this limit, and this limit goes to e. So you can check that out. You can do this problem as an exercise, or I'm sure you can look it up and be able to find text and videos that talk about this particular problem. So bottom line, you have the two fractions as your L'Hopitals Rule gateway. This is the form that you want to be able to use L'Hopitals Rule. And these 5 other ones down in the bottom are also indeterminate, but you have to rewrite the 5 other ones into a fraction, 0 over 0 or infinity over infinity, to be able to use L'Hopitals Rule. Okay. All right. So that's the breakdown of this section. And it's just a matter of doing a bunch of problems, and these are all limit problems. So good luck with this, and I'll see you again online.